In this video, we're going to look at another example of moments and centroids. The question here is to find the centroid of a region bounded by the curves y equals sine x, y equals 2 sine x equals 0, x equals pi, and density is equal to 3. The first step is to sketch the bounded region. So y equals sine x is simply the sine graph that goes through 0 and pi, that's its x-intercepts. Y equals 2 sine x has twice the amplitude and goes through the same x-intercepts, 0 and pi. All right, so let's label the top function f of x is equal to 2 sine x, and the bottom function g of x is equal to sine x. X is between pi and 0, and the density rho, this is a density, is 3. All right, so now let's apply the centroid formulas. Mass is equal to density rho times integral a to b, top function minus bottom function, f of x minus g of x dx. The density is 3. Integrate from 0 to pi, these are the x limits. Top function, f of x is 2 sine x. Bottom function is sine x. That's g of x. Integrate with respect to x. 2 sine x minus sine x is just 1 sine x. So mass is equal to 3 times integral from 0 to pi sine x dx. This is equal to 3 times integral of sine is cos, actually it's minus cos, so we get minus cosine x, evaluated from 0 to pi. Factor out the minus, we get minus 3 times cos x, evaluated from 0 to pi. Now apply fundamental theorem of calculus. So mass is equal to minus 3, putting the upper limit in, we get cosine pi, minus, put the lower limit, we get cosine 0. Cos of pi is negative 1, cos of 0 is 1, so we get minus 3 times negative 1 minus 1. This is minus 3 times minus 2, that's 6. This is the mass. Now let's look at the moment with respect to the y-axis. Rho, density, times integral a to b. The distance to the y-axis is measured by the x-coordinate, x times f of x minus g of x dx, which is the area element of the vertical slice. So this is equal to 3 times integral 0 to pi, x times 2 sine x minus sine x, the lower function, times dx. So this gives us x times sine x. We can certainly integrate that using integration by parts, but actually no integration is required. We can see that x bar, the x-coordinate center of mass, which is moment with respect to the y-axis divided by the mass, is simply pi over 2 due to symmetry. So we don't need to compute the moment with respect to the y-axis to obtain x bar, because the region is symmetric about x equals pi over 2, and the centroid of the region lies on the axis of symmetry. So let's write this down. So region is symmetric about x equals pi over 2. Let me write this better, about. And if you look at a diagram, you can clearly see that the region is symmetric about x equals pi over 2. This part, this right half of the region, is exactly the same as the left half of the region. It's like placing a mirror across x equals pi over 2. So clearly you can see that x bar lies on the axis of symmetry. X bar is pi over 2, and our goal now is to find y bar. And that requires us to find the moment with respect to the x-axis. All right, so let's look at the moment with respect to the x-axis is equal to rho integral from a to b 1/2 times top function squared f of x all squared minus g of x all squared dx. The moment with respect to the x-axis is equal to density, which is 3, integral from 0 to pi 1/2 times f of x, that's the top function, is 2 sine x all squared minus a lower function, which is sine x all squared and dx. So now let's simplify this. Moment with respect to the x-axis, 1/2 is a constant, passes through the integral, we get 3/2. Integral from 0 to pi Now 2 sine x all squared gives us 4 sine squared x minus sine squared x, so we get 3 sine squared x. 3 sine squared x dx. Now we can apply trigonometric identity, the half angle formula. Sine squared x is equal to 1/2 times 1 minus cosine of 2x. Trig identity. All right, so 3 is a constant, passes through the integral. The moment with respect to the x-axis is equal to 9/2 integral from 0 to pi sine squared x dx. Applying the trig identity, applying the half angle identity, 9/2 times integral from 0 to pi sine squared x is equal to 1/2 times 1 minus cosine of 2x dx. 1/2 is a constant, passes through the integral. The moment with respect to the x-axis is equal to 9/4 integral from 0 to pi integral of 1 minus cosine 2x dx. So the moment with respect to the x-axis is equal to 9/4. Let's integrate. Integral of 1 is x, because derivative of x is 1. Minus, what is the antiderivative of cosine 2x? It's going to be sine 2x, reversing the chain rule or U substitution with u equals 2x. So we get sine 2x divided by 2. Because, let me put this on the side, u is equal to 2x, just to be thorough, du is equal to 2 dx. And let me write u substitution here. But because it's easy, we just do it mentally. And let's close off the bracket and apply fundamental theorem of calculus from 0 to pi. All right, so we have the moment with respect to the x-axis. Let's put the upper limit and the lower limit, apply FTC. Putting the upper limit in, we get pi minus sine of 2 pi divided by 2. Minus, put the lower limit in, we get 0 minus sine 0 divided by 2. Sine of 2 pi is simply 0. Sine of 0 is also 0. So if we simplify this, we get moment with respect to the x-axis is 9/4 times pi. So sine of 0 is equal to 0. Sine of 2 pi is also 0. In fact, sine of any multiple of pi is 0. So we found a moment with respect to the x-axis, and we found the x bar earlier to be pi/2. And that's because the region was symmetric about x equals pi/2, and the centroid always lies on the axis of symmetry. So x bar is pi/2, and no integration is required. We found the mass to be equal to 6, and the moment with respect to the x-axis is equal to 9 pi/4. So we can now find y bar. Y bar is equal to the moment with respect to the x-axis divided by the mass. The moment with respect to the x-axis is 9 pi divided by 4, divided by the mass, which is 6. So we get 9 pi divided by 4 times 1/6. And we get 9 pi divided by 24. Divide numerator and denominator by 3, we get 3 pi/8. So x bar is equal to pi/2. Y bar is equal to 3 pi/8. If we decimalize this, let me put this into a calculator. 3 times pi equals divided by 8. That's 1.18. So if we look at the diagram, we can see that makes sense. Let's go back to page 1, and you can see on the diagram x bar is pi/2 and y bar is 1.18. Well, this is 1 here, this is 2 here, 1.18 is roughly about here. So x bar is pi/2 and y bar is 1.18. This is the centroid of the region. All right. Thanks.